Let's try to prove it the ladder theorem, at least in the simple way. So if we are taking the triangle from this triangle here, that includes the area y and z, and we want to see this triangle to figure out, for example, in what ratio is going to be this area y with this area y plus z. So first of all, let's see this triangle. If we are looking at this triangle, we see, for example, just let me take to make some more points because it doesn't look. Let's say this is A, B, and C, and let's say here is a D. And if we are looking, for example, at triangle ABC, and if we are looking at triangle AD, and let's say here is E, ADE, those triangles are a similar triangle because they share the same angle here, and because those are two lines parallel, and this one is in a 90 degree is inside, it means because they have two angles the same, the third angle has to be the same. So it means all the angles are the same, those are a similar triangle. And now if we are, according to the similar triangle, the proportion of these triangles are equal. And for example, if r divided by, let's say this distance here is t1, and this distance here is a t2. So the distance or the proportion of the side of the triangle r divided by t1, let me write here, r divided by t1 is equal with this side q divided by t1 plus t2. Q divided by t1 plus t2. And now if we are multiplying with the cross product here, r times t1 plus t2 is going to be equal with the q times t1. But in fact, those are the surface area. If we are multiplying both sides by 1.5, this side and this side, so we have the areas of those triangles. And now in R, so in R here is going to have the area of y. So whole area is going to be y is equal with the area of this big triangle ABC, which is a q. But a q here includes, this big triangle includes a y plus z. Y plus z. If we are taking the reciprocal in both sides, is going to be 1 over y is equal with the 1 over y plus z. So we proved this equation 1. And now let's see, let's prove equation 2. If we have the triangle, so the same triangle is what we had here, but now we have a little bit slanted. But those are parallel. Let's say P, this segment B, segment T, segment R, segment Q, all of them are parallel one with another. But now let's look in this side here, on the left side. If we are looking at the segment T here, or if we are looking at the triangle AGB, is similar with triangle AIE, because of both of them, they share the same angle, the angle here, and both of them, because those are parallel, those are associated angles and are equal. So this angle here and this angle I and angle G are the same, and angle A they share both together. The third angle has to be the same. And the proportion here, because those are similar, so P divided by the segment AI, so let me write it this way, segment AI is equal with the segment T divided by AI plus IG. AI plus IG. So those two segments. If we are using the cross product here, P in time AI, segment AI plus IG is going to be equal with the segment T time AI. And now if we are multiplying both sides by 1.5, so then we have a triangles by 1.5, and same thing here, 1.5. We have a triangle, but in the P here is going to include the triangle y plus x. Okay, we have a y plus x is equal. But the total here in a T, it has a total triangle, the total area A, B, C. So because it's the total, just let me write with the T that represents the total triangle, okay? And now, if we are taking the reciprocal here in this equation, is going to be 1 over T, so just let me put 1 over T in the front, is 1 over x plus y. In fact, let's say this is equation 2. And now, lastly, if we are taking equation 1 and equation 2, this equation 1, if we are going back a little bit, it was 1 over y is equal to 1 over y plus z. And we write in here equation 1. 1 over y is equal to 1 over y plus z. This was equation 1. And equation 2 was 1 over t was equal with 1 over x plus y. 1 over x plus y. So this equation 2. If we combine equation 1 and equation 2, we already get this one here. 1 over t plus 1 over y is equal with 1 over x plus y plus 1 over y plus z. What we already have here. So we already proved this ladder theorem.